Hello, I'm Kanon Ichige from Shibaura Institute of Technology. My poster is about two novel characteristics of mechanically induced long-period fiber grating. First, background. Optical fibers are now widely used for telecommunication. However, in recent years, the fibers have been researched for sensors because of its outstanding features. For example, low loss, small size, low weight, immunity to electromagnetic induction, and resistance to corrosion. Among such optical fiber sensors, my research is about especially for mechanically induced long-period fiber grating, mechanically induced LPFG. When a grating device, which has a lot of periodic protrusions, is impressed to the fiber, the photoelastic effect appears and the refractive index of the optical fibers changes. The protrusions period is called a grating period. It varies from 10 to a few hundred micrometers. LPFG is a kind of wavelength filter. Therefore, a certain wavelength of light is radiated during propagation. After radiated, the optical power of the transmitted light is be able to calculate by this formula. T is transmittance. Kappa is coupling coefficient between core modes and cladding modes. L is the length of the grating device. Kappa has pressure dependence, so LPFG can be used as pressure sensor. Next, methodology. As an experimental setup, a tunable laser and an optical power meter are used as a light source and a receiver, respectively. An automatic servo stand is employed to apply pressure to the grating device. The grating period is fixed at 6100 micrometers. Optical power meter measures the light at just 1550 nanometers. On the other hand, the wavelength of the incident light from tunable laser is valid between 1500 to 1550 nanometers. This figure shows transmission spectra of this experiment. When the wavelength is 1500 nanometers, the decrease of the output power is very small. However, the output power decreases markedly with increasing pressure at the wavelengths around 1550 nanometers. It's confirmed that characteristics of the mechanically induced LPFG can be optimized by tuning the wavelengths of a laser. In the other words, when the mechanically induced LPFG will be used as pressure sensor, the sensitivity can be adjusted by tuning the wavelengths of a laser. Thank you for listening.